Hello, this is Hossein Mohit. Welcome to the Principles of Conceptual Database Design video lecture. In this short lecture, you will learn how to create a graphical conceptual design of database before proceeding to its implementation and creation. Please remember this is only a summary lecture, so you will need to read the book completely and also do all the assignments and quizzes to ensure that you are performing well in this course and also in the exams and assignments. In the previous lecture, you learned about the basic concepts of the relational data model. In this lecture, we will focus on how to represent those concepts in a graphical and intuitive way. This will include some technical details which necessary for the creation and implementation of the database system. When it comes to conceptual modeling of a database system, there are generally two approaches. The first one, entity relationship diagram or ERD, and the second one, object-oriented modeling. The entity relationship diagram is the older technique for database design and is still widely used. However, in this course, we will focus on object-oriented modeling and the UML notations. This approach is more relevant for at least two other courses in our program, so Application Development 1 and System Analysis and Design. It is also becoming a dominant modeling technique as the application side of a database, where users interact with the databases, which is typically written in object-oriented languages. By using the object-oriented modeling technique for database modeling, you will maintain consistency between database design, implementation, and the design of the application layer. In this course, we will use the Unified Modeling Language, UML, to construct our object model, focusing primarily on class diagrams. Although there are many types of diagrams within UML framework, we will concentrate on class diagrams and how they relate to database model and relational model. Before we get into the class diagrams, let's familiarize with some basic concepts of the object-oriented programming and object-oriented design. The most fundamental concept in the object-oriented design is called a class, also referred to as an entity or set. A class is essentially another term for what we previously called as a relation or table in the context of the database management. It can refer to a concept or a thing. This could be something tangible, like a vehicle, or abstract, like roles, organizational units, sites or location, incident, events, or even concepts such as bank account or product design and skills. So what you previously learned as a relation or table, now it can be referred to as a class. Your textbook may also refer to classes as sets. So don't get confused. I prefer to use a standard term class, but when reading the book, you will see it referred to as sets. Classes can have attributes, much like a relation or tables. These attributes represent characteristics of the classes or entities. For example, in a class called employee, the attributes might be first name, last name, date of hiring, social security number, addresses, and other information relevant to the business context. Classes can also have methods, though we won't deal with these methods in this course. That's something you will probably cover in the programming courses and system analysis and design courses. Method represent the functionalities of the classes. For instance, for the class human, human as a class, a method might be ability to walk. The functionality might be ability to walk. Or, for example, for the class called customer, that would be a make a purchase. In database design, we don't focus on functionalities, only on data structure. Classes exist in a world of abstractions. They only appear in diagrams and code. For a class to become real, it must be turned into an object. For example, for a class customer, there could be thousands of actual customers, or and for a class like employees, there could be thousands of employees. But there is only one class that we call it employee. Each employee or customer is an object of that class or an instance, a real life existence of that class. A class is an overarching concept such as humans, animals, vehicles, employees, customers, locations, or sites. The actual installation of the concept is called an object. So an object has all the attributes and methods of the class. In database design, we refer these classes as problem domain classes. This means they exist in the domain of a business needs or business problem. Just pay attention. The word problem here doesn't imply something bad or troublesome. It refers to the business context or scenario you are addressing. One of the most challenging tasks for database designer is to ensure that the model accurately capture the business rules, policies, and processes. If a model doesn't reflect the real world or uh, business processes correctly, the database will be defective and probably it's leading to a failed project. So for the purpose of database design, we will only use the class diagram from object-oriented modeling to help us understand the business domain better and also represent it in a graphical and intuitive way and add technical details to it. There are also other diagrams within object-oriented programming and modeling, but for this course, as I mentioned, we are only concerned with the class diagram. We will learn more about the other diagrams in the other courses. Now let's take a closer look to a class diagram and the type of relationships that can be depicted using them. A specialization and generalization are the two most common type of relationships in the business domain, and they can be modeled using class diagrams. When identifying the classes based on the business processes and rules, it is often helpful to focus on the nouns and verbs used in those processes. Generally, nouns refer to classes, which indicate the entities, as you remember, and verbs refer to the relationship between those classes or those entities. Specializations and generalizations are hierarchical inheritance relationship. This means that subclasses inherit the attributes and characteristic of the superclasses or upper class. In later courses, you will learn that they can also inherit functions and methods. In these type of relationships, you can identify a superclass and subclass, and the relationship can be considered an is a relationship. For example, a man is a person. A person is a class that could exist in your database. Both customers and employees are considered persons in a systems. This is a relationship, is in a quotation relationship, a speech which is specialization and generalizations can either be overlapping or exclusive. For example, a person could be classified as either man and or woman. Okay, in this case, a person might fit into the disjoint or exclusive categories, meaning a person can only be in these one of these categories. As shown in the diagram, the person class has many attributes. The subclasses, which are men or women, inherit all of the attributes from the person as a class. But they can also have additional attributes that are unique to them. In another example, you might have a person as a superclass, okay? And the subclasses could be an employee and a student, such as when modeling a university system, for example. Here, the person can be both a student and also an employee, showing how subclass can inherit from the superclass while also having its own specific attributes. Now imagine a situation where classes are not in a hierarchical relationship like the last slide. So we no longer have an is a relationship, but within an organization, most of the classes are still connected to each other in one way or another. These connections are called relationships or associations, and they link two or more classes together. Similar to the previous concept, you should look for verbs in business processes, rules, and policies to identify these relationships. For example, in the context of a school, we know that a student can enroll as a verb in a course, or for example, students can take a course. So here, enroll and take are those verbs in these relationships. And here we have two different classes, student and course. A student may also be a subclass of a person. To show the relationship between a student and course, we connect two classes with a line, and the place for the verb like enroll or take, the one that we mentioned, the place is on that line. So you need to put it on that line. This defines the relationship. Remember, a relationship itself can sometimes be a class if it holds some necessary information to join other two classes. For example, uh, uh, when this happens, when it becomes a class and is called as an association class. So a class that connects two other classes, we call it as an association class. Let's see an example. Each student can take one or more courses, right? And each courses can have one or more students. This type of relationships is called many to many relationships because both sides can be associated with many instances of the other class. One student can enroll in many courses and one courses can have many students. So it's a many to many relationship. However, there's a point to it. In a relational database, many to many relationships are problematic. You need to break them down into the one to many relationship to comply with the referential integrity constraints of the relational model. In the world of relational database, it is we call it as a cardinal rule, and we can say it's an unforgivable sin to have the many to many relationship in a relational database. So to resolve this, we use those association class or an association table in that model. So in conceptual design, we refer to it as a association class, but when it comes to implementation, we call it as an association table. So this table or class holds the necessary information to connect the initial two classes, okay? In order to break the many-to-many relationship into the one-to-many relationship. Like the example we have here, student to course, and the enrollment is the association class, or in the implementation phase is association table. Now let's take a look at the cardinality or multiplicity, which indicates the number of instances of one class that can be related to the instances of another class. For example, if each person is associated with one social security number and each social security number is assigned to only one person, we have a one-to-one relationship. This means that for every instances of a person, there is exactly one corresponding instances of an SSN and vice versa. So we can see on the figure that the person has SSN related to the social security number, and we can see one on each side. So the left one is related to the social security number that assigned to one person, and the right one, which is next to the social security number, it says that the person is assigned to one social security number. But the point is, business rules often modify these cardinalities. For example, in the case of minors who don't have the social security numbers, the rule might be that a person can have a 0 or 1 social security number. This is called as an optional relationship or 0 to 1 relationship. So the second figure from the left in the middle one, you can see that when designing a database, it is important to account for these business rules. So here we can say that the person, there is a 0 dot 1 next to the person, entities, or class, and also on the right side, there is a 0 dot 1 next to the social security number. So it says that a person can have a 0 or maximum 1 social security number, and also vice versa. So next, consider another example. For example, a supervisor who manage multiple workers, and each worker has only one supervisor. So in this class, we have a one-to-many relationships. One supervisor can manage many workers, and also, but each worker is managed by only one supervisor. Again, if the business rules allow workers without a supervisor, this would change the cardinality from 1 to 0 or 1. So as we see here, a supervisor, there is a 1 dot 1 next to the supervisor class, and also on the right side, the worker, there is a 1 dot asterisk. So we'll read from left to right. So the supervisor can have a one or many workers, and we show this one with the 1 dot asterisk. And on the other side, a worker can have only one supervisor. So we show it with 1 dot 1 uh, supervisor next to the supervisor. So, but in terms of the generalization and specialization, let's look at the relationship between the person as a class and men as a subclass. On the right side, we can see the figure. Each instance of man is also instance of a person. So we have a one-to-one relationship between a generalization class, which is a person, and its a specialization class, which is man. This means that every instances in the man class must be related to exactly one instances in the person class. So cardinality is represented by notation in both UML and ERD diagrams. So as we mentioned, the one-to-one relationship might be represented by 1 dot 1. One-to-many relationship could be represented by 1 dot asterisk, and 0 to 1 might be shown as a 0 dot 1, indicating an optional relationship. So for the next slide, we are going to learn about another way to show and specify cardinalities, which we will not use in this course, but you are most likely to see this one in an entity relationship diagram and other diagrams related to the database management and design. So technically, it's the same reason. It's the same reason for using this, but in these just different notations. So it is important to know that this notation, even though we will not be using in our classes. It is for your general knowledge, and you will be aware of its this type of notations. So it is important to remember also that these notations reflect the real-world constraints and business rules that govern the relationship between entities, whether you are modeling these relationships in a UML or ERD. And understanding how this cardinality works is a key to designing a database that accurately represent the business processes. So this is called the cruise fit notation. So it is an alternative and older system for showing the cardinalities. As you can see here, we are using the same business scenario, but instead of using the numbers and asterisks, we are using dashes and also circles to denote, to show these cardinalities. So a circle means 0, a dash means 1, only 1. And when you have a crow's feet, it means many. So you can see that the relationship between, for example, person to social security. So just let me show you. So, okay, so we can see that the person and social security number, there is a one-to-one relationship. So each person has a 0 or 1 social security number, and each social security number is exactly to one person. So from person to social security, on the right side, we can see a circle and dash. That one shows uh, can be considered as a 0 or 1, but from social security to person is the 2 dashes. So it shows that there is exactly 1% for that social security number. And also the relationship between supervisor and worker is one-to-many relationships. So we can see that from the left side, each supervisor can have one or many worker. Okay, so there is a dash and a crow's feet. And also from the worker to supervisor, we can see that there is a just exactly one supervisor for each worker. And that single dash or bar is just shows that the maximum cardinality is could be just one. And also for the students and the courses, we can see that there is a many-to-many relationship. So each student can have many courses, but on the other side, courses can be taken by many students and also can be not taken by non-students. So can be also considered as a 0 as well. So that's why we can see the cross feet and the circle next to it. So this is exactly the method that people shows for the ERDs. Just pay attention again. Many-to-many relationships are a cardinal sin in a database design. So whenever you encounter them, you must resolve them by breaking them down into the one-to-many relationship using the association tables or association class. So in your final database design, I don't want to see any many-to-many relationship. So if I find any in your final design for your assignments, for sure there will be a penalty for it. Now let's talk about the class attributes and attributes that are also keys. So class characteristics are those that matters in your context. For example, in a healthcare context, recording the social security number might be an important attributes of the class, customers, or person. However, if you're designing a database for a small uh, restaurant, the social security number might not be relevant unless the person class refers to employees, in which class it could be important. So how you design the database and the context in which you are working will determine the attributes and characteristics that each class will have. Typically, nouns and adjectives in business rules and processes will refer to the characteristics of the and will refer to the characteristic and attributes that you need to record for each class. As you learned in the previous lecture, a key refers to an attribute or collection of attributes whose values are unique, can be used to identify each singular row in a relation or table, or each instances in a class. So a key can be internal, meaning it's meaningless and automatically generated like the student ID. And also it can be external, meaning that they have a meaningful attribute like the social security number. So in today's database design, we almost always go with the internal keys, as external keys are beyond our control. So once you identify the attribute that is good candidate for the primary key or combination of the attributes for a composite key, you need to indicate, you need to show it in a class diagram by underlying the attribute name. So in a class diagram, you will have the class name on top, followed by list of attributes, which with the primary key attributes that should be underlined. So at the end, you have probably noticed that I'm using many words interchangeably because they essentially mean the same thing. So to help clarify, let's create a connection between the logical and conceptual model. In the logical model, which we discussed in a previous chapter, a relation or a table refer to a thing of interest, or an attribute represent the characteristic of the thing. Like for example, the table for the students, the attribute was first name, last name. And a tuple is the instance of that things of interest, a row in that table. In other words, a relationship is also called table. An attribute is also referred to as a column, and the tuple is often called a row. So technically, they are all the same, just with a different name. So that was a quick review of the chapter 4. So as I always mentioned at the beginning, uh, this lecture alone is not enough to ace your quizzes, assignment, and exams. So you need to read the textbook and complete the assignments and quizzes that include in the book. So please let me know if you have any question. Email me. We can set a time to meet on our office hour, like the some students that already contacted me and we already met. So have a good week and good luck.